everyone, my name is Jordan Collins, and like in the previous project video, Stage 3, I am the software developer working on Darius Gray's software project, codenamed Alpha Project. This report covers Stage 4 for the semester project, a wrap-up report for the user stories and iteration completion and the release plan, as well as the comprehensive testing plan we followed throughout the project. Just like before, Darius and I communicated on a regular basis using social distancing techniques such as Zoom and phone calls. We met about 2 times over Zoom, discussing exactly how the testing plan would go for this project. We discussed the use of TDD throughout the project, as well as developing techniques and example cases for white box, gray box, and black box testing before, after, and during each iteration. During our earlier meetings, we clearly established his vision for Alpha Project, and thanks to careful planning from the beginning, we have continued to build and test Mr. Gray's software magnum opus. So thanks to this careful planning for each iteration and the testing for each iteration, the project is still slated for release on December 6th. So yeah, as you can see from the beginning, we had a ton of user stories, and our iteration planning went according to our original calculations. So we had a slight velocity. Yeah, so and again, thanks to careful planning from the beginning and with helpful feedback from Darius along the entire process, we were able to remain on schedule for that December 6th release. And we had a slight velocity slowdown during iteration 2. Oops. We had a slight iteration slowdown during iteration 2, but by reapplying velocity calculations, shuffling stories into future iterations, and other techniques learned in this course, we were finally able to finish up those remaining stories in iteration 3. And with iteration 4, everything went perfectly in line with our iteration release plan. So thanks to feedback from Darius, we were able to complete all of his must-have and should-have stories. And by practicing TDD and performing each variant of testing throughout the process, as well as carefully refactoring things as prescribed by TDD, we were able to test the system inside and out along the way. During the final week, we wrapped up some minor refactoring and had some customers and testers from our testing team do some end-to-end black box testing. Okay, as you can see, this was how we ended Stage 3, our Stage 3 report with iteration 1 and 2 complete, and work already projected for iteration 3. So we carefully decided how to proceed after the roadblocks that we did experience in iteration 2. All right, and this was our projected work for iteration 4. And as we progressed after our Stage 3 last report, we can proudly report that as of December 4th, we have completed iteration 3 and 4. All of the stories originally slated for the iteration 3 were completed, as well as the stories we carried over from iteration 2. Overall, this iteration we completed 22 story points. Again, if we had more carefully subdivided the geofencing user story from the original plan, we could have had a more accurate velocity for iteration 3. However, it's something we learned and we will bring with us into the next project. And as you can see here, we have our iteration 3 burn down chart. We had a slow start from days 1 to 3 with the graph not moving down the y-axis each day, just going steady across. But as we were cleaning up the mess we made during iteration 2, and with hard work and determination, and with the growing understanding of the code base and the tools we were using, we were able to get our work done by the end of this iteration. Right, and as you can see, for iteration 4, as of December 4th, we've completed all the projected work in this iteration. For this one, we completed a total of 14 story points during that iteration, and this means we also successfully completed all the must-haves and should-have stories instantiated by Mr. Gray. And here you can see our burn down chart, and everything here worked pretty perfectly. We had that 320 hours remaining, and it steadily went down throughout the iteration. All right, so this chart shows the final planned versus actual velocity we achieved during the entire project. So you can clearly see the slowdown in velocity from iteration 2, followed by an upward trajectory in iteration 3. Finally, we returned to the projected velocity during the final iteration. Again, it is extremely important to break down stories into manageable chunks. Some even advocate for stories no longer than 4 story points, as clearly illustrated by this chart. So while we only finished 8 story points in iteration 2, we made up for the lost velocity by completing 22 story points in iteration 3. All right, this chart represents the entire project burndown chart. Again, you can see the dreaded rising line as we finish iteration 2. The slow work performed in iteration 3 to complete our leftover stories from iteration 2, and then a steady realignment of the projected versus actual story point completion as we moved from iteration 3 into iteration 4. And a lot of times this kind of plan does not work out as expected. Often you will have to drop certain stories if you do not make your schedule, but nevertheless, we were able to achieve it in this project's case. All right, and so while with the final iterations noted and covered, we move into the testing plan presentation. Here we will denote and explain our testing plan with the usage of test-driven development, white box, gray box, black box, and some end-to-end testing performed during the duration of Alpha Project's creation. All right, so test-driven development. From the very beginning, we discussed with Darius Gray the application of TDD in respect to the creation of this project. As we are a strong believer in the efficacy and effectiveness of the practice, we began the process during iteration 1. As such, we broke the entire functionality of the project into discrete functional units. So before coding any one of the single functional units, we designed simple unit tests, which can be a form of white box testing for each. We would then let the test fail to ensure that everything was working correctly. Next, we would write the smallest, most simple lines of code to get the unit test to pass. Once that was completed, we would refactor the code and repeat the entire process on the next discrete functional unit. As the project was growing in size and complexity, it became more difficult to refactor and to write tests, but having a unit test for every single function in the project ensured that we achieved a code coverage of nearly 97%. Okay, so through the TDD facilitated project, we performed a plethora of white box testing. So in essence, white box testing refers to a form of testing where the tester has insider knowledge of the underlying code functionality in the code base. In this, the developers typically intentionally break their code to better understand how it functions, which is what you do in TDD. And this breaking of the functionality allows you to be able to better repair and debug the system. And if you do TDD correctly, you should not have to do a lot of this because you do have testing coverage for everything. So in this form of testing, the developer tests all branches and logic of the code, such as if statements or else statements. And they ensure that proper error handling and error catching is performed, so try catch errors and stuff like that, and ensures that the code is functioning as prescribed by the customer and documented within the code itself. And finally, ensures the system is handling resource constraints properly. In an example of white box testing that we performed, we had a case where we were checking the login code for SQL injection vulnerabilities. And there's a few ways to format these test cases. There are some with if-then or other kinds of formats. For this one, I followed the headfirst book. So for this, you can say test for the user login box will only accept standard characters used for usernames. So you would go through the steps next. So you would establish a connection to the login page, attempt to insert SQL language into the login field, send SQL commands by pressing enter, such as the star key to the username database. And then you would next verify that the login incorrect prompt was issued, and this can be done in a black box test as well. But for white box testing, you are also going to check the database code to ensure that no queries were executed. And finally, you would want to check the logging and the code for whether the database connection returned an invalid character exception. And of course, these things are not going to appear to a user or a tester who is doing black box testing. This is specifically for the cases where the programmer wants to understand the flow of their code and has a deep understanding of how the code is executing and how it's responding to other pieces of code. And another good example we had was ensuring that employees cannot clock in or out except at home or work. And this was one of our bigger stories in this project. And for one of the tests we ran, it is basically test for clock in rejection when employees are not at home or work. And so first you would establish a connection to the geofencing database for employees, send an incorrect employee GPS location command to the database, check for employee ID, home ID credential mismatch with previous command, ensure the system returns a "you are not able to clock in here" prompt to the user interface, verify that the system did not return a correct clock in command to the system, and then check the system for code exceptions. And ultimately, you would want to check also for cleanup, but that might go more into gray box testing. All right, for gray box testing, it is very similar to black box testing, which we will get to in a moment. Typically, you want this performed by system testing teams, not necessarily the programmer who might have a bias based on how much of the code they understand, but someone who has a little bit of knowledge, but not as much or not as little as someone who might be able to do a black box testing like your customer. So essentially the same in black box testing, but the tester can look at the surface level code. So these may include ensuring proper auditing and logging is occurring, ensure data is being routed to other systems correctly, ensure system added data information is correct, such as timestamps and things of that nature, and ensure that waste and scraps from the code building are cleaned up. So a good gray box testing case we came across was testing for losing connection when a manager attempts to send out a schedule. So the steps would be get an instance of the manager scheduling platform initiated, get an instance of the employee scheduling platform initiated. Within the manager instance, click the select schedule button and choose a large schedule file. Press the send button and then quickly log out of the manager profile, killing the instance. And then for the gray box part, you are going to check the logging information specifically here, which is not something that a black box tester might know about, but a gray box tester should know. So essentially check the code logging information for a data transfer initiated sequence, check the employee logging information for a data transfer receiving sequence, and check the employee instance received a schedule not received prompt, which a user will be able to see, but not in conjunction with those logging sequences. And then again, for gray box testing, check the code for any improper exceptions, which the user would not be able to do normally. All right, so black box testing is definitely the easiest to understand. This can be done with absolutely no knowledge of the code. They simply need to understand how the system should function to a user. So this can be performed by a testing team or even the customer or beta testers or something like that. So basically, you are testing the system based on only input and the resulting output. So you're ensuring that the system functions properly, ensuring that correct user input validation, ensure correct output results, ensure correct state transition. So this can be something for like a website where you are seeing if a page goes to another page and stuff like that. And then, of course, ensuring functioning boundary cases and one-off error handles. So this could be something like entering a credit card with exactly one too many digits for its credit card number and seeing how the system handles that. And for a black box testing case, we have a test for employee login validation. So this is one of the simpler ones you can do. You simply open an instance of the web page for the employee login, enter a correct employee login, enter a correct employee password, check that the UI prompt says you are logged in, and confirm that the employee can successfully enter their homepage and manipulate from there. And another one could be the inverse of that. So test for employee login with incorrect password, initiate the login page for employees, enter a valid employee username. You can also switch this up with a different test case, but in this case, it is a valid employee username. And then enter an invalid employee password for the username. Ensure that the UI prompt sends a incorrect username or password selected prompt, and then ensure that the system only allows 3 attempts before locking the account. After 3 incorrect attempts, ensure a prompt for a password reset appears. And these can be particularly important in security cases, which are another use for white box or gray box testing. But in this case, you are checking the user experience. But for example, you would not want the system to send back a incorrect username. If the username is incorrect, you would want it to send back both so that somebody attempting to hack an account would not be able to differentiate. Okay, and then we also performed end-to-end testing, which we won't go over too extensively, but this is a form of black box testing where you ensure that everything works seamlessly from beginning to end. So this could be performed by Darius, for example, which we'll have him perform before we release. But essentially, you could go from logging in with correct information, moving through a homepage, checking your posted schedules, checking PTO and requesting PTO time off, sending a message to a manager, receiving a message. And so these end-to-end testings are ensuring that a user experience is seamless and that nothing goes wrong during it. And of course, you would want to do these again we also did one for a manager as well, being able to post a schedule, being able to check their weekly employee logs for logins. But yeah, you would just do it from end to end. And those are the things you typically perform right before releases. All right. Thank you so much from my development team to yours. Thank you for watching. Customer satisfaction is extremely important, and the customer Darius is very satisfied with his project's functionality. The testing plans also met the customer's expectations, especially in regard to the TDD experience, and the product was actually slated for release tomorrow afternoon. So thank you for watching and have a wonderful day.